Good day, teacher. Hi, I am Marvin Balanon. For this video, I'm going to explain how to solve the assigned task for me, which is the number 14, and it's all about the linear programming. So let's start. Here's the problem number 14. The travel agency has sold 1,800 tickets for International IT Annual Convention in Singapore. The weekend package includes airfare, and there is a choice of two types of airplanes for the charter flights. Type A can carry 100 passengers and Type B can carry 300 passengers. Each flight of Type A aircraft will cost 9,000 pesos and each Type B flights will cost 15,000 pesos. The agency is allowed to lease no more than 12 planes. Each Type B flight requires 2 stewards and each Type B flight requires 3 stewards. No more than 30 stewards are available. How many airplanes of each type should be leased in order to minimize the cost? So in this problem, we need to find the minimized cost of each types. First, we need to put this problem in a tabular form. Here it is. So in this problem, let's assume the number of units of A to be X and the number of units of type B to be Y. Here's the total cost of type A and B, or the minimum cost. 9,000 X plus 15,000 Y. The constraints are type A 100X plus 300Y equal or greater than 1,800. Type B 2X plus 3Y equal or greater than 230. Next, we need to plot the constraints of the linear programming problem on the graph. Here's the constraints 1. Type A, or the x-axis. We need to use the intercept rules. Let x equal to 0 so that we can get the y-axis. And to the other side, let y equal to 0 so that we can get the x-axis. And here is the second constraints. We need to use again the intercept rule. Let x equal to 0 and let y equal to 0. And now, we get the constraints 1, which is the y equal to 6 and x equal to 18. For the constraints 2, we have y equal to 10 and x equal to 15. We can see that we have here one feasible region that lies. Then, we need to trace the extreme point of the graph and solve for the unknown coordinates. So we have here in the graph one coordinates of the extreme points. After that, we have to solve the intersection of the lines that satisfy the feasible solution using elimination method. So we have here in the graph one coordinates. To solve these coordinates, we need to use the elimination method. So we have the equation 2x plus 3y equals 30. We have to find the least common multiple. Then we have to substitute the value of x. So we have the value of unknown point. Next, we have to substitute the coordinates at the extreme point of the feasible region in the objective function. Here's our objective function. Minimize cost. 9,000x plus 15,000y. Then use all the points that we get so that we can get the lowest cost. Then, let's formulate the decision. Since in this graph, we can see that L is the lowest value of 138,000. Thus the L, 12 and 2 is the correct or the lowest value. That's all. Thanks for watching.